Hello and welcome. In this video, we are going to focus again on the transition of our P6 or P6 practice into our P6 modified practice. Now, in earlier videos, we focused on the setup and the similarities between the two versions of our application. And again, just a reminder, we are going to be shifting from our static memory allocation. In other words, we have fixed size arrays to a more dynamic approach. In other words, we are going to use a combination of malloc and realloc. Now, this particular video focuses on the project associated with the simple inventory management system. And specifically in this video, I am going to be looking at my import products function. And I want to begin by looking at the original P6 practice. And you'll recall that basically we passed a file name and then we passed an array that we allocated in main. In this case, we called it our import results. And we also passed by address an n or an integer to keep track of the number of elements that we were able to successfully import. Remember that these are arrays of structures. And again, just a quick reminder, we want to take a look at the original function to think about the process here. We've essentially validated each of our input arguments. This time around, we're going to be doing this a little differently because we aren't necessarily bothered by the fact that our import results may in fact be equal to null. As a matter of fact, we're going to assume that we are given a null array and allocate the memory appropriately, but we still need to make sure that things like n is in fact not equal to null, and then so on. So again, the general process is the same. Check to see if the file name is valid, attempt to open the file, but where it differs is that unlike in the early example where we have to keep track of the number of n or rows read in, and then essentially stop when we hit a maximum value, we can continue to go and essentially reallocate or allocate more memory as necessary. So to begin with, I want to go over to our P6 modified practice, and we can go ahead and get started. So the first thing that we want to do, much like in the other function, is we simply want to check to make sure that our file name is not equal to null, or that the string length of the file name is not less than 5. Where did I get 5 from? Well, that just happens to be the shortest feasible CSV file name that can be used. If you think about it, .csv will take up 4 characters, and then a single character for the file name means that anything less than 5 can, in fact, not be a valid file name. And again, then continuing on with this theme here of validation, we simply have a print statement that says, error, please provide a valid file name. Now, you can, of course, borrow some of the code from P6. I am simply going to go through and rewrite this function. You are more than welcome to try to figure out what the changes are. But either way, at this point, we set our results equal to exit failure. And again, we return our results. Now, we can do the same with our else if for our n. And if our n is equal to null, we're not going to worry so much about allocating this particular value. If this does happen, we've got some sort of problem. In other words, whoever called this function made a mistake, in which case we simply want to say error, please provide a valid n, followed by a new line. And again, results are equal to exit failure. Now, technically speaking, we would also want to make sure that the variable that is holding our import results is also not equal to null, but we are going to focus in on the value stored in our imported results. In other words, does it point to a valid place in memory? And so what we're going to do is we're going to focus now on opening the file and then allocating the memory as we need it. And so we need a couple of more variables here. One is going to be a file input variable. We also need to have local variables for each of the fields associated with the file for the purposes of our fscanf. And if you recall, that is going to be the ID, the name, the type, the description, the price, and the quantity. And also notice the data type for the first 4 will be a char. For the 5th one will be a double, and technically for the 6th one, it will be an int. And so we could start off with a char for the ID, and whether you use lowercase or uppercase doesn't really matter too much. We'll have a char for our ID, a char for the name, a char for the type, and then also a char for the description. Now, it would probably be a good thing at this point to take just a second to look at the structure up at the top of the file and just make sure that your field sizes are the same. In this particular case, I've made a mistake. I've allocated 50 for the description. We should probably do the same thing in our import. And then we can do our int then for our quantity and a double for our price. And again, it doesn't really matter too much in which order we do this in. In this case, we have all of the fields that will ultimately be stored in our structure. Now, let's get to the business now of actually opening the file. And so the first thing that we want to do is say input is equal to fopen, and we want to open whatever file name was passed by the user. We want to open it for reading, and then of course we want to check to see if our input file pointer is equal to null. In case that it is, we simply printf an error, failed to open, and then we can specify the file name by specifying a %s for a placeholder, and then simply put in there the file name that was passed by the user. And at this point, no matter what, we simply want to set our results equal to exit failure. And again, that's going to be what is returned from this function. Under the else branch, then we can proceed with reading the values out of the file. Now, at this point, we have some steps that we have to take in order to be able to initialize this process of reading and parsing the values into our array of structures. The first and easiest step is to simply set our n equal to 0. Now notice I'm putting the asterisk in front of that to indicate that I'm wanting to set the value at the address of n equal to 0. And then we also want to do the same thing with our import results. However, what we want to do is we actually want to force the type based on the product properties and make it a pointer, and we're going to cast then our null. And so the idea is that basically what we're doing is we are setting the import results equal to a product properties null pointer. Now, ideally, this could be done outside of the function. And then you also should consider checking to see if our import results is already pointing at some allocated memory, in which case you may want to consider freeing that memory. But in this case, since we have complete control over the process, we are simply going to initialize this as null. At this point, what we want to do is now set up a while loop, and we can do this with a compound condition, first checking to see if our results are equal to exit success. And the second condition is going to involve our fscanf. Now, this particular one is going to get a little long because we're going to be looking at our input file pointer, and we're going to have a fairly long format specifier. Why? Well, because we have 6 columns to look at, and we also want to indicate that it is separated by commas. And to avoid the same problem that we saw earlier with the %s being too greedy, we are effectively going to look at a pattern of not comma. And so effectively we have not comma separated by a comma, not comma separated by a comma, not comma separated by a comma, and again, not comma separated by a comma, then a %LF, and then a %D. So very carefully, what we want to do is we want to specify the 6 format specifiers, starting with the not commas separated by the comma. And so this will be the first one, second, third, fourth, and then the %LF for the price, followed by a %D and a new line for the quantity. Now, at this point, then I probably want to consider going to a new line. We can actually go ahead and bump this down now just so that we can see this a little better. And then we will piece by piece plug in the fields that we need using the address of. And so in this case, it's going to be the address of ID, the address of name, the address of type, the address of description, the address of our price, and then lastly, the address of our quantity. And then we want to check to make sure that the entire fscanf is not equal to end of file. And essentially what we're going to do is we're going to loop through each one of the rows looking for that matching format specification. And if we, again, do find that, then what we need to do is we need to allocate enough memory to store n+1 elements in our array. And when I say elements, why don't I go ahead and change this real quick to structs. The idea is that we want to allocate enough room in our array to store a new structure. Now, the way we can go about doing this is we can start by leveraging the value of n. And since we are assuming to start off with a null value or a empty, or rather no block of memory, even if you want to think about that, and essentially our import results points to nothing, then the simplest way to go about doing this is to go ahead and allocate a new block of memory using realloc. Now, I am going to go ahead and create one more temporary variable just because it is good to use with realloc, and that will allow for us to check to make sure that we were in fact successful at creating a new block of memory. And I will simply create another variable of the same type as our import results. And so what we're going to do is we're going to have a product properties pointer, and we're simply going to call it the new results. And the idea is that I'm going to use it to simply check to see if I can allocate more memory. And the way we do this is we say new results are going to be equal to, and we always want to remember with our realloc and our malloc function to go ahead and cast to a pointer, in this case, a product properties pointer. And we want to use the realloc function, and we will simply use the address of the original block of memory, in this case, our import results. And we want to specify that we want a block of memory that is n+1 times the size of one of our structures. And in this case, that is going to be our product properties. Now, before we go any further, let's take a second to think about this. Remember that we have our product properties, which is our structure. Our size of function will simply return the number of bytes associated with a single product properties Why do we do n+1? Well, the idea is that I'm trying to grow the array by one element at a time. I'm going to use the original location in memory to start with, and then if necessary, realloc will return a new location in memory and then shift all of our data over. And I'm going to cast that address to a product properties pointer and store it in our new results. Now, the reason that we do this is because sometimes realloc fails. And in this case, we simply need to check to make sure that our new results is in fact not equal to null. If it is, or the else, then basically we have a problem and we can have a printf error, failed to allocate memory, followed by a new line. And then of course, then our results then become exit failure. Now, if you'll notice here, the way we have our while loops set up, if results now becomes exit failure, it will kick us out of our while loop. So basically we either will exit gracefully by virtue of fscanf running out of things to read, or we will exit as a result of our results changing from success to failure. Now, under the true branch of the if statement, what we do is we simply assign then the value stored in our new results into our import results. And so at this point, then we essentially have access to that new block of memory. Now, particularly, we would probably want to do a little bit of checking to see if, for instance, that old block of memory needs to be freed. But again, we'll talk about that in a later video. To begin with, then, what we want to do is we simply want to assign each of the fields with those local values. And I'm going to do this a little strange. I'm actually going to start first with the quantity and the price, and then I'm going to move to our strings. And so the easiest one will be then to access using our import results. Notice I have parentheses around the entire operation here. So in other words, we are looking at the address of our import results. And what we want to do is we want to access using our n, the particular structure, in the array. And in this case, we'll focus first on the price. And we will assign then the price that we have collected in our fscanf. Again, let's do this one more time. We'll do our import results. We're going to specify our n. And in this case, we're going to focus on our quantity. And before we go any further, let's go ahead and build this. And you can see that we don't have any errors yet. And so what we can do now is we can focus on the ID, the name, the type, and the description, which all of those are character vectors or strings, and particularly we know these as strings. So in this case, what we'll want to do is use our string copy function. And again, with an abundance of parentheses here, remember that we want to provide our destination first. So again, we're going to use our import results, and then square brackets. I missed one of my parentheses there, square brackets in. And for our first one, we want to use our ID, and then we want to pass to it the ID, that local variable that was filled with our fscanf. And we can then simply repeat this pattern for each of the strings, of which there are 4, our name, our type, and then lastly, our description. And then, of course, the last thing to do inside of this true branch of our if statement is just simply to increment our n to reflect the fact that we have now found a new row. And so at this point, this process will simply repeat until, again, we have a problem allocating memory. In other words, we ran out of memory, or we have ran out of rows in the file to read. And so again, we'll take just a second to go ahead and build this. We probably forgot, and yes, we did. Real quick, we need to remember that if we've opened the file, then we need to remember to close it. At this point, we can simply build it. And then we can go up to our main to test it. And so what we can do is, for instance, under our search, under our ID, in other words, where we are calling our /ID, let's take just a second to attempt to call our import function, so our import products. We can specify the file name. We will call it our products.csv. We want to specify the pointer to the start of the array of structures, which we have not yet declared. We will go ahead and call this then our import results. And specifically, we want to pass it by address, and we also want to pass by address our n. Now, what we need to do is come up here to the top of our main and simply go ahead and declare a product properties pointer, and we're going to call it import results. And we can go ahead and declare an n. And again, then we're going to pass both of these essentially by address. Now, the one thing to point out real quick is that much like what we did inside the function, we can also take just a second to initialize our import results by simply casting it using the product properties pointer and casting it, or rather casting the value of null. And essentially we can do this both in main as well as in the function. You can sort of think of this a little bit like coming along and simply initializing our n equal to 0. At this point, let's go ahead and build it to make sure that we don't have any errors. We can come back out to our command window and we can run our search ID, and you can see that it's calling our search and calling our ID, but we don't know if it's actually doing anything. So let's generate just a little bit of noise in that. What we can do is we can simply have a printf, and then we can check to see what the value of n is. Again, I'm going to use the %d placeholder, and I'm just going to check to see what our n is. We're going to build it one more time and then run it once more, and you can see that n is 10. And so far, it's looking pretty good that we have our import function working. Before we leave this video, let's do one more quick thing. I'm going to leverage my index variable, and I'm simply going to loop through my import results. And to do that, I'm going to start off with index equals to 0, index less than n, and then index plus plus. And then inside of here, I'm going to simply print one of the fields inside of each of the structures. And so, for instance, I might be interested in just looking at the IDs associated with the items. Those are all going to be %s's followed by a new line. And we will simply look at our import results and our square brackets index, and we will then specify the ID. So again, we're going to build this. We can come out to our command window and we can run it, and you can see that I am successful at reading in all of the IDs. Now we're going to stop this video here. Hopefully you can now see the similarities between our P6 original or P6 practice and our P6 modified. In the other videos, I'm going to focus on the differences in a few of the other functions, but as I mentioned in an earlier video, there are more similarities in this project than there are differences. The big advantage to what we've just done is we have saved a ton of memory. For instance, in our P6, we allocated 100 times the size of one of our structures. And if you are curious to know what that truly means, we can simply say printf, and we can use our size of function to populate the size of value here using the %d. We will say the size of a product properties struct. And just to avoid any warnings, I'm going to go ahead and cast that to an integer. And again, if we build this real quick, we can actually see how much memory we have saved. So again, I'm going to run this. You'll notice here that a single structure is 120 bytes. So that means that if I had allocated 100 of them, I had actually allocated 12 kilobytes. Now, the catch was that if I was reading in a small file like this with only 10 rows, I was actually only using 1.2 kilobytes, or 1/10 of that. The rest of the memory allocation was wasted. So hopefully you found this video useful. If you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.